Now we are going to look at how a quadratic equation could be formed using given roots. Okay, first of all, we start with the general form of the quadratic equation. So let me pick up my pen. So if we have, this is the general form of the quadratic equation: ax squared plus bx plus c equals to 0. As a matter of fact, quadratic equation could be with any variable. So here we are writing in terms of x. Somebody may decide and say ay squared plus by plus c equals to. So but the most important thing is that the coefficient of whatever variable square must not be 0. If this becomes 0, remember, this must not be equals to 0, because if this becomes 0, you boil down having bx plus c, which is a linear equation. So but you can have it the other way around. B can be 0 or c could be 0. Anything could be 0, but this one must not be 0, otherwise it is no longer quadratic. So if that is the case, remember, whenever we had this quadratic equation, we solved and we end up having two roots. Sometimes the root could be identical, sometimes it could not be. But then I want to give you a hint. You can solve a quadratic equation either by using the almighty formula or the quadratic formula, or by using the method of completing the square. Or maybe you try to factorize and it is not working out. It is not giving you can't just find two numbers that you can multiply to give you the product of the coefficient of x squared and the constant term, or you sum it to give you the b, which is the coefficient of x. So in such a case, you need to test something. There is something they call the determinant of the quadratic equation. The determinant d is b squared minus 4ac. So anytime you evaluate this, you have a quadratic equation, plot the values into this, and you end up having a negative number inside this square root, it means that it's a complex root. You cannot evaluate it. So but what about a case where it is positive? If it is a positive, then it is called real root. Real. This other one is called complex. Complex. You cannot evaluate it using ordinary quadratic method. So, but in a case whereby you evaluate it such that b squared minus 4ac becomes 0, it is called real and equal root. So the quadratic equation is said to have real and equal roots. Equal roots, meaning that the roots are going to be repeated. If it is 3, then it is 3 twice. If it is 2, 2 twice. If it is minus 2, minus 2 twice. So that is just it. But then these are just the things I need you to know. Now, the next thing I'm going to show you is that, for instance, you are given a root, or you are given a set of roots to form a quadratic equation. First of all, you have to know that this is a quadratic identities. So meaning that if you have your first root to be alpha and then the second one to be beta, then the quadratic identity says that alpha plus beta, which is the sum of the root, is going to be minus b all over a. And then the product, which you normally multiply, remember, you normally multiply the coefficient of, that is a, with this. So it means that c all over a is the product. So every other identity are derived from these two basic identities. So what about you have alpha square and beta square? So you are going to use this to factorize this. Remember, you don't have this in quadratic equation. You have to convert it to be of the form alpha plus beta or alpha beta. So what do? You factorize. If you have alpha square, for instance, if you solve a quadratic equation, one of the root is maybe 2, the other one is 3. Then somebody say form a quadratic equation whose roots are 2 square and 3 square, meaning that the square of the root you are getting here, of course, you are going to form an equation that will have the other root 4 and the other one 9. Let us see how we can manipulate it now. That is exactly what we want to do. But then, remember this quadratic formula. If you have alpha square plus beta square, there is no place you can find it in quadratic equation other than factorizing it and saying alpha plus beta square minus 2 alpha beta. if it is alpha square minus beta square, you are going to put it of the form, because you don't have any formula connecting the quadratic equation to alpha square minus beta square. You are going to like convert it to alpha beta and alpha plus beta, which is alpha plus beta all square minus 4 alpha beta. Then this cube, if you have cube, it's going to be alpha plus beta cube minus 3 alpha beta plus times alpha plus beta. So every other quadratic function are derived from this one. So somebody can have alpha 4 raised to power 4 plus beta raised to power 4. What do? You can simplify by saying this is the same thing as alpha square plus beta square all square. Then you factorize. By the time you factorize, you expand. So every other one are built from this first principle. Okay, we are going to look at the scenario listed below, and it says if alpha and beta are the roots of the quadratic equation 2x squared plus 4x plus 6 is equals to 0, find the equation whose roots are listed below. Number 1 all over alpha and 1 all over beta. It means that one of the roots is 1 all over alpha, the other one is 1 all over beta. Number 2, alpha square and beta square. Number 3, alpha cube and beta cube. Number 4, 1 all over alpha square and 1 all over beta square. Number 5, alpha plus 1 and beta plus 1. So we are going to start from the first one. Number 1, solution. Number 1 says 1 over alpha, 1 all over alpha, and then 1 all over beta. Mind you, in quadratic equation, let's reflect back. When we have the quadratic equation 2x